first order linear equation. So a first order linear equation can be written as a sub 1 of t dx over dt plus a sub 0 of t x and then is equals to e of t. So like in our algebra, this is like a sub 1 of x squared plus a sub 2x plus a sub 3. So it is like a polynomial equation, but the only difference is that this has a derivative on it. So if you can see an equation like this, you can say that it is a linear ODE. So you have some function of time with derivative and then some function of time and then a pure function of time. So this is a first linear equation with a variation of parameters. So our step in solving this, so step 1 is we divide the equation by a sub 1 of t. So step 1 is dividing the equation by a sub 1 of t to get the standard form dx over dt plus r of tx is equals to q of t. R of t is the one that you get by dividing a sub 0 over e sub 1. So that's your r of t, and then your q of t is the one that you get when dividing e of t divided by e sub 1. So this becomes your non-homogeneous equation. So next step is step 2 is we try to make this equation into a homogeneous equation. So by doing that, we will try to dx over dt plus r of t x is equals to 0. So that's it. That's how you make the equation becomes a homogeneous equation. So you equate that equation into 0. Your non-homogeneous, you equate that with 0. So that's become a homogeneous equation. Then step 3 is you try to solve for the homogeneous equation. So the solution will look like, or the answer will look like, x of t is equals to k h t. So that's how the solution will look like. And then the step 4 is you try to solve, or the solution to number 1 to step 1 will look like, you let vary it with a parameter. So looks like variation of parameters. So this becomes, the equation becomes x of t is equals to k of t and then h of t. So the constant that you get in the step 3, you let it vary by time. So you vary it with t, or the time. So that's your step 4. Then step 5, so after you let the constant vary it with the parameters like the time, you substitute the number 4 into number 1. So step 5 is substitute number 4 into number 1, which with doing some math, so with doing some math, so this will yield us k prime of t, h of t is equals to q of t. And then you try to solve for step 6 is you try to solve for the k prime of t. So try to solve for k prime of t, and then integrate to get the k of t. So this will look like k of t is equals to the integral of k prime of t dt, so plus c na here. And then step 7, or the last step, is use number 4, or the solution from number 4, use number 4 to find the true solution. So x of t is equals to k of t times h of t. So this will be your answer. So that's your answer. So let's try to solve a problem, example. Let's try to solve an example, example number 1. So example number 1, that's 3 dx over dt plus 2x is equals to 1. So we'll try to make this equation into a standard form. So how to do that? We divide this. We have some equation. I have some equation. We have some function here. So this is your a sub 1. So you divide that. We will divide this equation by 3. So this becomes dx over dt plus 2/3 x is equals to 1/3. So this is now your standard form, which is our non-homogeneous equation. And then we'll try to solve this, or we'll try to make this equation into a non-homogeneous equation, which becomes dx over dt plus 2/3 x is equals to 0. So this is now your homogeneous equation. And then your step 3, so this was your step 1. So this was your step 2. So step 3 is you try to solve the homogeneous equation. So dx over dt, so trying to group the similar functions or the terms. So dx over dt is equals to negative 2/3 x, and then the equation becomes dx is equals to negative 2/3 x dt, which also becomes 1 over x dx is equals to negative 2/3 dt. So you have some function of x, and then you have some function of t. So now you integrate that. 1 over x dx is equals to the integral of negative 2/3 dt. So what will you get is the natural log of x is equals to negative 2/3 t plus c. So now we'll try to raise that into e. So the log or the ln will be cancelled. So x is equals to e to the negative 2/3 t plus c. Or it can be written as x is equals to e to the c times e to the negative 2/3 t. And then you have this constant now. So you try to vary it with time. So the form or the true form of the true form solution of the non-homogeneous would become x of t times k of t times e to the negative 2/3 t. So this is now your solution to the homogeneous equation. And then next is we try to plug this into our non-homogeneous equation. But before that, we will again derive the x of t is equals to the k of t e to the negative 2/3 t. So the equation becomes, so I'll try into one, plug into the non-homogeneous. So your non-homogeneous equation is dx over dt plus 2/3 x is equals to 1/3. But you try to get this dx over dt or the derivative. So you derive your solution, you derive this to get the dx over dt. So now dx over dt is equals to the derivative of k of t e to the negative 2/3. So that's uv plus vu. So the equation is k of t, so derivative of e to the negative 2/3 t. So that's negative 2/3 times e to the negative 2/3 t plus e to the negative 2/3 t times the k prime of t. So now we have this dx over dt. So try to plug this into the equation or into the non-homogeneous equation. So this becomes k of t negative 2/3 e to the negative 2/3 t plus e to the negative 2/3 t k prime of t plus 2/3 times your x, which is k of t e to the negative 2/3 t. So your x is k of t e to the negative 2/3 t is equals to 1/3. But as you can see, you have this 2/3 times k of t e to the negative 2/3. We can try to look back, and then you can see that we can try we can we can so we can cancel this out, this negative 2/3 e to the negative 2/3 t times k of t, and then 2/3 k of t e to the negative 2/3 t. So that would be the magic of this step. So now your equation becomes k prime of t is equals to 1/3. This is e to the negative 2/3 t. So trying to manipulate this, k prime of t is equals to 1/3 e to the 2/3 t. And then you integrate this equation. So you integrate this equation, k prime of t is equals to the integral of 1/3 e to the 2/3 t. So this becomes k of t is equals to 1/3 over the 2/3 e to the 2/3 t, then plus c. So you can cancel this out. So k of t is equals to 1/2 e to the 2/3 t plus c. So that's your k of t, and then your k of t, so your homogeneous solution was x of t. As you remember, x of t is equals to k of t e to the negative 2/3 t. So substituting the k of t that you get, so 1/2 e to the 2/3 t plus c times e to the negative 2/3 t. So your x of t is 1/2 e to the negative 2/3 t times the e to the negative 2/3 t becomes 1/2, and then plus the c times e to the negative 2/3 t. So this is your solution. So this is now your solution. So another example. So but before that, we try to recap. So first is we have this problem, or we have this equation 3 dx over dt plus 2x is equals to 1, and then try to divide that by 3, or your e sub 1. So dx over dt, the equation becomes dx over dt plus 2/3 x is equals to 1/3. That's your non-homogeneous equation. And then your non-homogeneous equation, you try to solve it, or you try to make that into a homogeneous equation. So you equate that with 0. So the equation becomes dx over dt plus 2/3 x is equals to 0. And then solving the homogeneous equation, dx over dt is equals to negative 2/3 x. So you transpose this 2/3 x into the other side of the equation. So dx over dt is equals to negative 2/3 x. Then dx is equals to negative 2/3 x times dt. So transpose this dt into the other side of the equation naman. So this becomes dx is equals to negative 2/3 x dt. And then again transpose your function of x into the other side of the equation, or we are trying to combine the like terms. So 1 over x dx is equals to negative 2/3 dt. Next step is we integrate this. So 1 over x dx is equals to negative 2/3 dt. And then the integral of 1 over x dx is equals to the natural log of x is equals to the integral of negative 2/3 dt is negative 2/3 t plus c. So by cancelling the natural log, so we try to raise that to e. So e to the ln x, this would be cancelled. Then the answer would be x is equals to e to the negative 2/3 t plus c. And then try to simplify the equation, e to the c times e to the negative 2/3 t. And then your constant, you make your constant vary with a parameter of t. So the equation or the solution of the homogeneous equation would be x of t is equals to the k of t e to the negative 2/3 t. After that, you plug the solution into the non-homogeneous equation, which is the dx over dt plus 2/3 x is equals to 1/3. But before that, we try to solve for the dx over dt, which is your derivative of the homogeneous solution. So the derivative of k of t e to the negative 2/3 t is k of t, or the uv plus vu. So the derivative of that, so k of t times that negative 2/3 times e to the negative 2/3 t plus e to the negative 2/3 t k prime of t. And then you plug this into the non-homogeneous equation. So k of t times negative 2/3 t e to the negative 2/3 t plus e to the negative 2/3 t times k prime of t plus 2/3 k of t e to the negative 2/3 t is equals to 1/3. And as you can see, we can cancel this out. So the equation becomes e to the negative 2/3 t k prime of t is equals to 1/3. And then k prime of t is equals to 1/3 e to the 2/3. So integrating that, k prime of t is equals to 1/3 e to the 2/3 t. Then your answer becomes k of t is equals to 1/3 over the 2/3 times e to the 2/3 t plus c. So by simplifying the equation, you get k of t is equals to 1/2 e to the 2/3 t plus c. And then this solution, you plug this into the solution of number 4. So the solution of number 4 is x of t is equals to k of t e to the negative 2/3 t. So where your k is equals to 1/2 e to the 2/3 t plus c times e to the negative 2/3 t. And then multiplying this equation, so you will get the answer of 1/2 e to the 2/3 t times e to the negative 2/3 t. That's become 1/2. And then c times e to the negative 2/3 t is equals to c e to the negative 2/3 t. So this is now your solution. So next problem,